Hi, everyone. Hope you are all well. Welcome to another session of Network Tech Talk. I am Derek Johnston, your host. And in this episode, we're addressing redefining networks of the future. Specifically, we will dive into the growing network architecture and technology choice of virtualized RAN. More and more network operators are making the move to virtualized RAN to address service and revenue opportunities, as well as the constantly growing data demands on the network in a more flexible and efficient manner. To provide us with insights into the innovation and growing momentum in network virtualization, I am joined today by Alok Shah, who leads strategy, business development, and marketing for Samsung's networks business. He's been at the helm of guiding the U.S. Strategy for the business for, I believe, about 5 years now, and has a breadth of experience, including roles in Samsung's mobile device business, as well as other firms across the industry. Hi, Alok. Welcome. How are you?
Thanks, Derek, for having me. I'm doing really well.
Excellent. Glad to hear it. So again, thanks for joining us today. But before I turn it over to you, for our viewers, if you're looking for more information on today's topic, there's a link below to our website, which again should be at the bottom of your screen. So again, thanks for your time and insights in advance, Alok, and I'll turn it over to you.
Great. Welcome everyone to another Tech Talk webinar. We're doing this one a little bit differently. Usually our sessions tend to go pretty deep on a particular topic of interest in the industry. This time we wanted to kick off the new year with a broader view of the major trends we're seeing in the market at a high level, and kind of some specifics around Samsung Networks strategy and our positioning relative to others in the space. So let's just dive right in. And as Derek said, if you'd like to learn more, we would love to share that with you, and please reach out to us. So I think over the last 2 years, we've all talked ad nauseum about the new normal and how things are changing. I'm pretty excited about some of those changes. I'm hopeful that we never lose the ability to do curbside pickup of our groceries. But there are some things that actually slowed down a little bit during the pandemic, and we expect to come back in a big way. And one of those trends is growth in wireless networking. We've seen an inexorable trend over decades, really, in growth of usage on mobile devices. And over the last couple of years, we've been home for a large part. We've been sitting on our Wi-Fi networks, but that mobility aspect is coming back in a real big way. And so the question becomes, how does an operator handle that growth in traffic, right? And fundamentally, there are a few different tools. So one is around technology, bringing new technology and new features to market that make better, more efficient use of the spectrum that's available. And so the move from 4G to 5G brings in a number of key features: massive MIMO, beamforming, and radios that can support a much higher density of antenna elements, right? So in the 4G world, we had 4T, 4R radios, maybe an 8T, 8R radio. And then with 5G, we've introduced substantially higher order massive MIMO. So moving from those numbers up to 32T, 32R, 64T, 64R, and in the case of our millimeter wave solutions, we have as many as 1,024 elements inside a very small package. So technology is one big piece of the solution. Antenna density and massive MIMO is a key piece, but there are a whole bunch of other technologies that have been introduced in this transition. I won't try to go into all of them, but really important ways to drive higher capacity in the same spectrum, or by more efficiently leveraging what's available. The second piece is more spectrum, right? And in 5G, we've moved from using basically spectrum below 3 gigahertz in the 4G world up to spectrum that's between 3 and 6 gigahertz pretty heavily, but also millimeter wave spectrum that starts at 24 gigahertz and goes all the way up. And both of those bands are used in different ways, and we can get into that in more detail. But fundamentally, new spectrum is critical. It creates bigger data pipes, much more bandwidth that carriers can put to use. And then the third piece of this puzzle, excuse me, is more sites. Being able to densify your network, to split cells, to be able to take spectrum and bring it to a smaller area in order to get high population density areas. That's critical as well. So those are kind of the traditional tools that operators have had to work with. And in 5G, all three of them have been really, really important. But fundamentally, we've talked about this curve a lot over the years. Costs are going to go up over time if we continue to do things the way we always have, right? So all of these different solutions, whether it's new technology, new spectrum, or densification, are driving a potential increase in CapEx and OpEx, right? And for operators, revenue has been increasing, but not increasing at the same pace. And so what do we do about that? So the key, we think, is software, right? And this is a quote that Mark Andreessen popularized a decade or so ago, that software is eating the world, right? And we think that applies in not just cloud and enterprise applications, but also more and more in the mobile network. And for us, that means virtualization. So what is virtualization? Fundamentally, the best way to think about it is moving from dedicated hardware elements that each perform one task to a platform, a hardware platform and a software platform that enable a set of different applications to be supported. So, in this image, one way to think about that is the smartphone. The smartphone was a remarkable platform that drove huge amounts of innovation because it enabled a whole host of different software applications to be driven on the same hardware and software platform. And so in the network, it's very similar. Over the years, over decades and decades from 1G on, we've had dedicated hardware elements in the radio side and the baseband side, all the way through to the core that have driven this industry forward. But what's happened now is through new capabilities, new technologies, the platforms are much more flexible and capable of supporting a host of different applications. So if we think about that more tactically around what a base station looked like over the last few decades, in 2G you had a big cabinet at the site. You had everything integrated. You had air conditioning to keep things running. A tremendous amount of cost, right? It's cost from space, cost from the cranes that you need and the forklifts to get the equipment in there. And then also the upgrade cost, right? With dedicated hardware, you don't have that flexibility that you need as an operator to be dynamic and to be able to keep up with the needs of users. In 3G and 4G, we were able to separate the radio and the baseband. We were able to certainly improve the architecture quite a bit. And then in 5G, we've moved away from this dedicated baseband hardware to a more flexible platform that's driven by disaggregation. And why is that important? Because it gives the operator flexibility that they've never really had before in their network, but they don't lose the quality that they've always had in the network, right? So this is still telco grade solutions, redundancy throughout, but it's also scalable and flexible. You can bring in new capacity through new software instances. You can add new features and new services very, very easily. So that's that gets to the cost part of the equation. But before we keep going down that path, let's talk a little bit about revenue. Why is virtualization important to increasing revenue? So a bit of history on the industry, right? We have seen tremendous growth as an industry thanks to an incredible growth in users, fundamentally, right? We went from phones in the hands of a select few to phones in the hands of a reasonable number of people in select countries, to now phones in the hands of just about every adult human on the planet, right? And those phones certainly do more and more and more, right? And so the operators have been able to drive growth in their business both through more subscribers and through those subscribers doing more things, right? Driving usage overall in the network. In 5G, we anticipate that continuing by extending network capabilities beyond people to things, right? And we've all talked as an industry about the importance of 5G in enabling enterprise use cases, IoT, industrial applications, AR, VR, gaming, right? All of these use cases are going to drive more devices on the network, and those devices may not be entirely smartphones. So how does that work from a nuts and bolts network perspective? There are a couple of key technologies here, mobile edge computing, MAC, and network slicing. But both of those are really made feasible through the use of virtualized RAM, right? Because in the case of edge computing, being able to leverage a common processing platform for compute and storage is critical. And for network slicing, being able to carry that slice all the way through the antenna is critical. And we'll talk a little bit more about that here in the next slides. So edge computing is fundamentally about how to drive lower latency services for consumers and enterprises. And it's really all about bringing compute and storage as close to the edge, as close to the user as possible, right? And you know, that's not really the topic of today's discussion. I'm sure we'll talk more about MEC in future tech talks, but fundamentally, there are a whole host of use cases that we see that are quite interesting that over time in the coming years are going to be enabled by having more computing at the edge. You know, and whether that's AI-based video analytics, gaming, transportation like cellular V2X, all of those things require low latency connectivity. And then slicing is really about this transition from a network that had one pipe for all intents and purposes for all applications. And of course, there's been quality of service and certain things that you can do, but pretty limited flexibility there, to a network that has multiple virtual pipes within it, right? That can enable all kinds of different use cases. So we can go for users that want to do the best high-def gaming, they need bandwidth, and so they would be on a bandwidth slice, right? For a user that's an industrial IoT set of use cases where it's around sensors and IoT, they're all about long battery life and high density of connections. And so they would have their own different slice, and so on, right? But vRAN is critical to that because it drives, like I said, the architecture that enables these sorts of new technical capabilities. And so it becomes a stepping stone. By getting a vRAN architecture into your network as an operator, it becomes much, much easier to introduce these new services and these new revenue streams that come from these services. So that's what's really interesting right now. You know, in our industry, every 10 years there's a new G, and that G drives a transition for the network and potentially disruptions as well. But we're in the midst of actually seeing two different transitions hit at the same time. 5G and the move to virtualization. And for Samsung, we view that as two very, very important opportunities for us. And we'll get a little bit more into the Samsung network story from here on. So I won't go through all the details, but Samsung is a pioneer in 5G R&D and 5G commercialization. We started our work on the research side back in 2009. We had proof of concept systems in the field as early as 2014, collecting data, demonstrating the different capabilities that 5G was going to bring. We were first to commercialize pre-standard 5G with the 5G home service in October 2018 in the US. We were part of the first commercializations of 5G NR commercial service in Korea and in the US in mid-2019. And we've continued to push that forward, including last year when we were able to bring first commercialization of 5G vRAN using massive MIMO in the U.S. market, and so that was a huge set of accomplishments, and this vRAN shift, we think, is perhaps the most important of all of them, and you know, fundamentally, I think there remains a sense of questioning whether vRAN is the right path forward for operators. And what we found and what we've demonstrated is that the technology limitations have really started to disappear. We are seeing equivalent performance in the vRAN, even with mid-band spectrum, even with massive MIMO radios, than what we've experienced with hardware-based BBUs. So a few basics around Samsung Networks leadership. We are a strong contributor to the standards activities at 3GPP and elsewhere. We are a leader in essential patents for 5G, and contribute heavily to the overall ecosystem, working with partners around the world. We have a substantial footprint at this point of 5G and 5G ready radios around the world. We don't compete in every market. We work very closely with the most technology forward operators around the world to bring new technologies and new capabilities to their customers. And in the 5G era, we've entered a number of new markets with operators that want to be first to market there. And fundamentally, there are three pillars to our sort of technology leadership. If I set aside, IPR and standards capabilities, it's really around the silicon, the chips, the hardware that's enabled by those chips, and then the software that we've put so much effort lately into driving. So I'll start with the first two, and we'll get into the rest. So we've talked for most of the session about virtualization, the importance of software replacing hardware. There's of course a portion of the network that simply can't be replaced with software, right? That's what's going on in the radio, and that's where we start. But the radio is also an area of tremendous innovation, and it's driven by chipsets, by advanced, customized semiconductor innovation. And Samsung is an absolute leader in that space. We are, of course, one of the largest semiconductor companies in the world. We have tremendous expertise in chip design and manufacturing, and that has been applied to our network business. And so whether it's in the modem or in the RF, we have continued to innovate in chip design, and that enables smaller, more power efficient products. It enables higher performing products, and the latest greatest features for our customers. We have shipped over 200,000 5G system-on-a-chip solutions. They're operating in the field. This is an area where we're quite proud of our leadership, and we believe it's an area of tremendous differentiation. It is hard to design and manufacture chips at quantity, and we think it's a Samsung strength. If we look at the 5G chip innovation over time, what you notice is that it's an ongoing leadership position, right? So we started building custom 5G silicon back in 2017, 2018, and that portfolio of chips has continued to grow. But also you'll notice that we continue to push out new generations of those chips as well that are more capable, more power efficient, and enable us to continue to have that lead on the competition, where we are able to drive substantially smaller, more power efficient, and more capable radio solutions. And one that I'll talk about for an extra minute is around our massive MIMO radio. This is, as I said at the beginning of this talk, a really important technology in 5G. It is the enabler, multi-user MIMO is the enabler to get substantially more capacity out of the same spectrum, right? And there's a lot that goes into making it work well. There's, of course, the engineering around getting 32 transmit, 32 receive chains, or 64 transmit, 64 receive chains into a small form factor radio box. But there's a lot that goes on the software side as well with beamforming. And Samsung has innovated with a beamforming SoC that brings a lot of computation to this beamforming challenge, but also puts that computation at the radio so that you're not wasting compute cycles trying to do that work over on the baseband side. So architecturally, we think there are some important steps that we've taken, and it brings our hardware expertise and our software algorithm expertise to bear here. So then that leads into software. And I'll start where the virtualization really kicked off, and that was in the core. So Samsung launched the industry's first commercial virtualized core back in 2015. And over the last 6-7 years, we've been continuing to push new innovations in virtual core. Moved to a common core for 4G and 5G. We recently launched standalone core for 5G, which is going to drive these new use cases that rely on low latency and high availability. We have a very strong core business, and now we've taken that virtualization capability and brought it into the radio network. And the scale of what we've accomplished so far is, I think, really important to stress. So globally, with leading operators around the world, we have introduced vRAN at scale. So in the US, we're working with a leading technology operator around wide-scale commercialization of virtual RAN, starting with low-band spectrum and now moving to the mid-band, which is, of course, much wider channels, much more computation. In Europe, we've announced last summer that we're building the first wide-scale vRAN in that continent. This is in the UK. Really good progress on that front as well. And then in Asia, Japan specifically, we're bringing vRAN solutions to operators there as well. So there's a real global element, and there's a real scale element to what we're doing. These are not proof of concepts or trials. These are large-scale commercial deployments with thousands and thousands of sites already running. So why Samsung when it comes to vRAN? And the answer is really around our ability to hit the sweet spot of what operators are looking for. So the first piece of it is they're looking for innovation. And as a challenger, it is our job to bring innovation to this market, right? And so we are working closely with the operators to understand what their end state architecture looks like, and we're helping them to get there. Like I said in the previous slide, we're introducing and commercializing these virtualization capabilities for them. But there's another piece of this, and that's the reliability story. Operators, are running a very large, very complex network for hundreds of millions of users in many cases, and they need to know that their suppliers have stability across a number of different areas, right? Stability in their ability to invest over time, stability in their ability to sort of be here and be financially strong for generations to come. That's all very critical, and that combination is really what differentiates Samsung. We are bringing the latest, greatest innovation to our customers, and we're doing it behind a broader organization that's not going anywhere. So our virtualized RAN ticks all the boxes that operators are looking for. It's a cloud-native containerized architecture. We support massive MIMO capabilities, and like I said, this is commercial in the field, mid-band massive MIMO 5G. We have also done vRAN with dynamic spectrum sharing, so that an operator that wants to use 4G and 5G in the same spectrum can do so efficiently on a vRAN. We are supporting not just 5G, but multiple technologies on a single architecture. And we're driving acceleration so that we're not relying just on the basic x86 platform, but can bring more computation to drive higher capacity and better economics and power efficiency for our customers. So then there's actually a fourth pillar to this that we have not talked about yet, and that's where we're headed. And what that is network intelligence, bringing automation and orchestration to what has become quite a complex system, right? Networks, especially with 5G, are more and more complex to manage, and so we think it's really critical for more automation, for more intelligence to be driven into the network. So if we start with automation, it's really around collecting data, analyzing that data, and then applying it to optimize performance in the network. It can happen much more quickly than humans can do it, right? And so you're saving on OpEx costs, you're minimizing errors, and by having this very flexible virtualized architecture, you can make these changes dynamically and really quite quickly. And then the other piece is, like I said, around network intelligence. How do we leverage artificial intelligence and machine learning in 5G to bring more dynamic capabilities to the network in areas like energy efficiency, right? How do we reduce the active electronics usage when a network does not need its full capacity, right? How do we make network slicing work really truly dynamically so that the users that need a specialized set of performance parameters can actually get that very quickly, right? We think that's going to be enabled by automation and artificial intelligence in our networks. And I'll close with an important point that goes back to an earlier statement around Samsung's willingness to invest in the space. So Samsung announced last year that over a 3-year period, the company was going to invest $206 billion in post-pandemic growth. And there are a number of different categories where that investment is taking place. One of them is next generation telecommunications. And so that's not just 5G, it's 6G, and 6G research is well underway. Samsung is certainly a leader in that space as well. And so what's interesting, though, is it's not just next generation telecommunications investments that will benefit our customers. There's also investments going into semiconductor technologies, and there are investments going into artificial intelligence, robotics, and a number of areas that are fundamentally going to be key 5G use cases and revenue opportunities for operators. And so it's really a combination of different areas where Samsung is making huge, meaningful investments that will drive benefits for our operator customers. And I'll close here. Samsung brings expertise in chipsets with our in-house design and development capabilities that lead to innovation in our product sets, both hardware and software more and more. And then finally, we're driving these new investments into network intelligence that will drive down costs and improve performance for operator networks. And we'd love to work with all of these operator customers to continue to drive innovation going forward. With that, Derek, I'll hand it back to you.
Excellent. Thanks, Alok. Really appreciate your time and sharing perspective and insights. It's a fascinating time kind of in our space, right, as you noted, and a lot of broad industry changes that are happening, both at the user level and the technology. So really appreciate your time. Thanks.
Absolutely. Thank you.
And thank you all for joining us today on Network Tech Talks. Stay tuned for more upcoming episodes and for more insights and engagement on industry topics with us. Please follow us on LinkedIn, Twitter, and YouTube. And with that, have a great day. Thanks, everyone.